This talk is going to be about more access. We're going to start to jump in at a more advanced area, and we're going to start to accelerate the code that we write. I'm taking the training wheels off. Hi, my name is John Kakabara. I'm the Chief Architect for Radius, and we're going to be working with our training domain and our car access service. In the last session, we started to advance our get car operation a bit more, and we thought that the car operation was fairly well written and fairly clean, and it is, but it does a number of things, doesn't it? It gets a car from the DAO, it gets a person list, it cobbles those items together, and then it finally maps. One could start to argue that we are breaking the single responsibility principle. I would agree, even though it is a clean, written, fairly small class, it's doing a number of things. Now, one could argue, yes, it is breaking SRP, but what's the harm? It's still small. Okay, I agree that it is a somewhat of a gray area. However, if you break this out into a repository, it will be easier to test, and it will be more extensible later. So let's do that. What I have done is I have created a get car repository. So let's look at that. It is a very good idea for all of your repositories and all of your processor classes, which we haven't discussed yet, to take in a request and push out a response. Just like we do for operations, we do it for repositories as well. We try to keep this request response pattern no matter what kind of class we are creating. So I have created a getCarResponse class, and it is simple. There is a car and there is a validation results. I have also created a request object, and it's simply a car ID. I've exported the iCar repository after creating it. There's only one method in that iCar repository. And I've set the part creation policy to non-shared, meaning that this is not a singleton. Since it's not a singleton, I have to make sure, if it was a singleton, I would have to make sure and be very careful about instance variables and lock them where appropriate. But again, this is non-shared, so I don't have that particular issue. I'm importing the car DAO and the person DAO, and what this thing does is it does just about the exact same thing that the operation does. It has the same methods, in fact, pretty much copy and pasted. So let's go back to our operation and see what we can do to clean this up a bit and make it more applicable to the SRP. We clearly do not need to import the car DAO or person DAO any longer. What we do, however, is import the iGetCar repository. And I might have that spelled wrong, so let me go get that. Oh, get car repository. And this should be get car repository. Whoops. Okay, let's see how that works now. Go back to our operation, and here we go. That looks fine. We still need the map. The repository's job is not to map the car entity. It's simply to get the car entity. So we will keep the map. We can write a method called invoke get car repository, or simply we can just keep it as assigned car, and I think that still tells us the story. We certainly don't need the assigned person or the cobble. Let's change what we're doing here, and we're going to say that var response equals get car repository dot get. Something's wrong. What's wrong? Oh, my variable's wrong. So get car repository dot get car, and it wants a new get car request. And this is pretty much standard how we format this. We're going to say car ID equals request dot car ID. We will then set our response dot validation results equal to the response dot validation results from the get car repository, and we will set our underscore car to the response dot car. We no longer need the cobble or the assigned person, but we do need the map. So that stays like that. And thus we have changed and we have brought the repository into play. This operation now follows the single responsibility principle a bit better, in that its job is really to get the car from a repository and simply map it. Okay, let's just clean this up a little further. Take out the person list. And we have a using statement here that's problematic. So we will clean that up. We still have something that's red. And instead, we don't need a semicolon. And now we're green. Never leave a method, never check in a method that is not green, by the way. That's really important. Everything should be green with the exception of generated code. And generated code doesn't matter. So there we go. Let's continue our discussion. And let's go back to the car access model. Blow this up a little bit. And you can see that we have a get initial state command. This is a popular name for an operation, and the get initial state will generally return to its consumer, most probably a manager, all of the state that may be needed for a complex web page, or doesn't necessarily have to be a page, but something that the consumer is calling for that is just more than a car or a car type. We don't want to be too granular, too chatty with our services. We rather be chunky, and get initial state will return, if we look at the state response, a car type, a list of car types and a list of fuel types. Now, you can imagine that if you have a web page and you're showing a car and you might have a drop down of car types and a drop down of fuel types, then this is what this get initial state will do for you. Not only return the car, but allow you to appropriately assign those drop downs in the GUI. So how would we go about coding the get initial state operation? Well, I think we're pretty much set up for it already. At least we're set up with a good start. So let's try doing this. The get car operation is going to do a lot of the same things that sorry, the get initial state operation is going to do a lot of the same things that the get car operation does. So let's give ourselves visibility into the get car operation. Let's see what we need. We probably still need a car map. So let's steal that. And we need access to the get car repository. So we'll steal that. Good. And it even sounds like we want to do this. Same thing that the get car operation does. So we'll just steal that. And we will also take our private variable. So at this point, we have pretty much duplicated what is in the car operation. Now we want to add to that. I don't know if I want to save that or not. I guess I will. What does our request look like? Our request does not have a car ID, and it sounds like we should have one that I think would make sense. Oh, it does. Get initial state request. Car ID is there as an integer, and it is. So request. I see what the problem is. This should be get initial state response, and it should be get initial state request. Good. That looks better. And we should have a car ID here. And let's clean up this red. Get initial state operation. What is it? Get car list. Okay, so that means we have a problem with our model. Let's look at the get initial state operation. So the input data contract should be get initial state request. And the response should be get initial state response. Let's save the artifacts. That cleaned up our red. Let's clean up our using directives, and now we agree. So we have successfully got our car. Basically, we're mimicking what get car operation, but now we have to add to this because the model tells us that we want to return a list of car types and fuel types. Let's import those DAOs. car type, whoops, DAO, and it's crying for the DAO. And let's put in fuel types. Fuel type DAO, fuel type DAO. Great. Now let's assign car type list, assign fuel type list. Good. And let's make these methods. And we'll make this method. And now let's go fill in those methods. Let's continue with this assign fuel type list. So what we can do is, let's say fuel type list equals fuel type DAO dot, what do we have wrong? Fuel type DAO dot fuel type cache. I'll explain it in a second. All list storage dot to list. Now, what's this thing, the fuel type cache? Frameworks has a built-in static cache. When we click on the entity and we say that the is type table is true, then it's going to create a static cache, a static list for all fuel types, and that can be used here. So I'm going to get all the fuel types. Obviously, it's dangerous. I know that there are only a very limited number of fuel types. You wouldn't want to do this, say, on a person table when there's thousands of objects. So then I can say var map equals IOC manager dot resolve I fuel type map, and then I will say underscore response equals map dot transfer fuel type list. It doesn't like something, response dot fuel type list. Okay, that works, but we know that this would be much harder to test. So let's take the fuel type map and let's put it someplace else. Import public fuel type map, fuel type map get set. And now we can just use this. Fuel type map. That's better. However, I don't want to do this unless everything else that came before it is valid. That looks better. I think the only thing I will do is I will call this list instead of fuel type list. There's only one type of list. Shortens it a little bit, and it makes it'll be easier to copy this code because I'm going to need something very similar for the car type list. And I'll give myself the car type map. So I just have to change a couple things here. And that looks pretty good, except for it doesn't like list. So let's see what's going on with that. Here's the problem. We need to change this to car type map dot transfer list. And I see that I have one yellow. We can take away this. Let's just do a quick smell test and see how this looks. Assign a car, map a car, assign car type list, assign fuel type list. One could argue that this pattern is asymmetrical. And while in building architecture, asymmetrical is not necessarily a bad thing. In computer architecture, asymmetry tends to be a code smell. With regard to this method, look what I'm doing. I am both retrieving the cars and I'm mapping it in one shot. One could argue single responsibility problem there. So I might want to map car type list and map fuel type list. And what I would need then is I would need a private list of entity.fuel type and call this fuel type list, and private list entity.car type, car type list. Bring in the collections. Okay. Now let's make these methods. Let's make this method. Then we can just switch this around easily enough. And let's put the mapping of fuel types here and the mappings of car types here. Let's throw our early return in. And now our early return here. And then we need to change this to fuel type list and this to car type list. And put this guy here and this guy here. Now let's take a look at our table of contents. So we're dealing with cars, we're dealing with the car, we're dealing with the car type list, and then we're dealing with the fuel type list. I want you to take note of the white space. White space is really important because it separates an idea. And just like we're writing a letter or a story, I think of white space as paragraphs. So assign car and map car is one paragraph. Assign car type list and map car type list is another paragraph. Assign fuel type list and map fuel type list is yet another paragraph. So then very cleanly and clearly and concisely I can see what's going on. I think that is a world of difference than reading this. I think that looks a lot more difficult to read. Separate that, nice and clean. We have some yellow here, let's check that out. We'll clean up our using statement. How many lines of code? Still not bad. Far less than 200. Check our methods out. They're nice and small, clean, concise, easy to read. How about our branching? Except for early return, no branching. I think a lot of you probably heard me say that I don't use if statements in my code because they decrease readability and increase complexity. And I don't even count these things as if statements. I know technically they are, of course, I'm not a dummy, but you really don't even have to read them because you know they're always going to be there. And there's no branching really of any significant note there, and there's no nested problems. So I just kind of skips over that and it just reads what it needs to read, nice and clean. So that would be my get initial state operation. Next up, we're going to talk more about caching. Now, Frameworks allows for this static storage. So let's look at the car type DAO for a moment. And let's see what we can see here. Creates this thing called a iCar type cache. And what else can we learn from this? Still has our basic methods there. And this is interesting now when we're looking for a value. We get by ID, but it doesn't go against the database. It goes against the car type cache. So it won't hit the database every time. So this is useful. It is. But if we have a distributed caching system, then I much rather use the distributed caching system. Why? Well, if we have multiple servers on a farm, say 5 or 6 servers, and we have to use a portion of that server space for its memory space for caching, let's say that, I don't know, there's 300 or 400K of caching here. If you start to multiply that by the number of servers, servers, then we're truly wasting memory. But not only that, if I need to update the car type cache for any reason, then I only have to update it in one place. Further, my hits to the database. If I have 5 or 6 servers, then I would be hitting the database 5 or 6 times for all that car type cache data. Multiply that by 2, and I'm up to 10 or 12 hits to the database for the fuel type data. That's a lot of unnecessary hits, and sometimes it's worth it, sometimes it's needed because the institution is not using a distributed cache. Well, we are, so we'll see how we're going to do that. Now, there is one other trade-off, and that's in performance. I can't imagine data retrieval much faster than hitting a dictionary that is local to the process. You can hit a dictionary and find keys and find data in the dictionary in sub-microsecond time. I mean, really, really fast O to the 1 time. If you go out to a distributed cache, the data must be serialized first because it goes over the wire. And you will incur network latency, and you will incur other types of performance. It's not as fast as being local. Well, how fast is it? I've done a lot of timing tests, and of course speed will vary with network latency and location, but you can get information on a particular ID, or you can get information on multiple car types, and usually a millisecond or less, a couple milliseconds depending. Now, how fast do you need to be? If you're doing this in a loop 5 million times, then that's going to be extremely slow. If you're getting it once or twice, a millisecond here or there, or even 5 milliseconds is not going to make a difference in our situation. So we choose to reap the benefits of a distributed cache, and that's going to be our next discussion.